Hi, my name's Andrew Greenfield, and today I'll be your narrator on the Spectrum Virtualize for Public Cloud Redbook video that focuses, in this case, on just the Amazon Web Services. We'll talk a little bit about Azure, but Azure has its own video. First and foremost, I'd like to do a huge shout out to everyone pictured on the screen. You'll see me at the bottom, but everyone else has been fantastic to work with here at IBM. And they have all contributed a lot to the various chapters in the Redbook. That's called the IBM Spectrum Virtualize for Public Cloud. But it's also being rebranded as Storage Virtualize for Public Cloud, as you can see on this white slide here. And that's what we're also going to be focusing on, is the updates here in 2023. If I could, just to recap, so yes, when you see the acronyms SV for PC as well as SVPC, you'll see that's part of the overall rebranding that we're moving from Spectrum into Storage Virtualized for Public Cloud Architecture. So let's talk about SV for PC. First, it provides all the features and capabilities as our on-premise flash system arrays. Two, more importantly, this is the easiest way you can start replication in less than 20 minutes to either the clouds. Three, the fact that you can spin up multiple of these instances in various clouds, including the same cloud. So you can have up to 3 in a given system. So that's a great way to have a nice disaster recovery and high availability, or safeguarded copies, immutable snapshots. It's all comprised of 3 virtual machines each using RHEL 8s. And you can choose different deployments. So you can save money on various different CPU and bandwidth options for your IOPS needs, as well as different disk needs on the back end. SV for PC is very easy to deploy. First and foremost, get your IBM ID. And if you don't have an IBM ID and an order number, very easy to go to IBM's website, Passport Advantage, sign up for one, and then order the capacity there for the entitlement. That will happen in step 2. That's right, in step 2, simply then use that same IBM number in either the Azure or the Amazon marketplace, and we'll be focusing on Amazon in this video. Grab the IBM Spectrum Virtualize for Public Cloud, and remember it's being rebranded SV for PC, SVPC, or Storage Virtualize for Public Cloud, and click on Deploy. And we'll go through that later on in this video. Now, the great thing about Storage Virtualize for Public Cloud is it's very simple and easy to understand. As we mentioned earlier, you have 3 nodes, and each one of them is a VM. The first one is the Quorum node, and then the other 2 are the subsets, or the SV for PC nodes. And underneath that, because we're talking about AWS, you have the Elastic Block Store, or those managed disks underneath, and you can deploy more after the fact. Each of these are inside a single VPC, but you can deploy more in that same VPC, or into other VPCs, or including other clouds. Now let's take a look at what it looks like from an on-premise hybrid cloud architecture. Of course, you can do this all solely in clouds, or multiple clouds as well. On the left-hand side, you can do NVMe hosts. That's right, because on-premise, NVMe works very well. And not only that, on-premise hardware allows us to virtualize other storage. So as you can see, FC or iSCSI storage, but we can virtualize over 500 other vendors' arrays on-premise. But in the cloud, right, we're going to be using AWS Elastic Block Storage, or EBS, and you can deploy various different disk types to match different CPU types during deployment for different bandwidth or CPU needs. And let's talk about those virtual machines. Basically, we, during deployment, have many different options of VM sizes, and the ones you want to focus on are only the actual nodes, not the Quorum virtual machine, because the Quorum isn't going to be doing any of the work. So you have a low, medium, and high, and we'll show this during the deployment videos. And we also have some slides that showcase some of the performance benefits of each type. As we talked about some of the different performance characteristics, here it is in a nice table. As you can see, the C5.4 extra large is the smallest that we found for deployment with its bandwidth, or megabits per second, versus the C5.18 extra large, which has quite a bit more bandwidth. Now let's take a look at the AWS Supported Disk types for the backend. As you can see at the top, IO1 gives up to 64,000 IOPS. Of course, on the slower side, and also the cheaper side, is SC1 disks, which are far less. Basically, you need to think about this during the deployment, but even after deployment, you can deploy some of these other disk types and add that as an easy tier, so you can span your disks, or you could considerably do this as a different pool of disks inside your SV4PC, and that way you can have different workloads on different capacities on the back end. Now, there's a very big benefit to using the brand new GP3 over the GP2 is it's cheaper and faster. There's almost no downside to using GP3 over GP2 because it saves you quite a bit on storage cost per month. And don't forget, you can turn on deduplication as well as compression inside our SV4PC appliance. So this is a very nice benefit during deployment as well as for additional disks that you do later on. Let's talk about one of the newest exciting features, volume groups. So now, instead of using consistency groups, by putting all of your LUNs or volumes into a single volume group, you can simplify your replication as well as snapshots, scheduling, and many other things in a nice, simple to use GUI. So not only can we talk about safeguarded copies, we'll talk about that next, but this is how you can easily take snapshots of entire sets of volumes all with one easy command, as well as assign policies or scheduling to those particular volumes inside that volume group versus just individual volumes. One of the most exciting features we've introduced over the last few years is safeguarded copies. Now, this is a Delta immutable snapshot. That's right, immutable, which is going to be great against cyberware and ransomware efforts. Why? Because you can take it either on-premise or in your cloud environment. Since it's on or in the actual array, we can recover instantly. So once you go back through your various different snapshots, and you can look at them with the internal snapshot policy, which you've seen on here, as well as other scheduling, we can then recover to a different volume for testing, as well as then overwriting the original production data or replicating it back to another instance of Spectrum Virtualize or Storage Virtualize, either in the cloud or on-premise. One of the other new exciting features is that we are embracing multi-factor authentication. So we can do it not only with IBM security, but we also have Duo security as well. Now, just in case you forgot, we also can augment our single sign-on with not only IBM security, but also Microsoft's Azure Active Directory, even in AWS, or if you have a different LDAP provider, we can do that as well. One of the other exciting features with volume groups that we can now do is what's called policy-based replication, or PBR. So using that same volume group methodology, we can assign a policy for how often you want to replicate a volume from one place to another, either SV4PC to another SV4PC or to an on-premise. So that means that if you want every 10 minutes for your volume group to be replicated over to another instance of SV4PC or on-premise, you can do that, or vice versa in that case. The only thing you are limited to is, of course, realities of how much you are trying to transmit over whatever links. We've also enhanced our replication over IPSec. So in case you don't know about this, this is the means of how we transmit information from one instance to another. We're making sure that all the data in flight is secure using IPSec with various different certificates. And this includes inside AWS as well. So that means you won't have to worry about any external vendors for encryption mechanisms for replicating the traffic between your various clusters. Especially in today's secure environments, we're making sure that all of our SV4PCs or even our on-premise flash systems are very secure. Please take a look at this table, which shows the various port numbers, which you'll need to make sure are available through various different firewall mechanisms, either inside the cloud or even on-premise through your various VPN and other mechanisms. Now, we'll be showing some of the workarounds using Bastion hosts in the upcoming deployment video, so stay tuned. Now let's take a look at another feature that we have. So for on-premise hardware support, as in flash systems, we can now replicate not only to SV4PCs, but we can replicate to the Amazon S3 bucket as well as Microsoft Azure buckets. This is using transparent cloud tiering or snapshots. So instead of replication of an entire LUN, you can replicate your on-premise or just your snapshots from one SV4PC or SVC to another. And this allows obviously even multi-cloud backups of those snapshots. Now let's get into the actual demo. But before we actually get into the install, we need to make sure we have our own key pair. And if you don't know anything about key pairs, no problem. It's a way of encrypting communications between two disparate points. So let's do this inside the EC2 instance. And you can see that I will start scrolling over on my left-hand side to be able to create a brand new key pair inside my EC2. Feel free to bring your own though. You can see that I don't have any created. So I'll create a brand new key pair and we'll be using this for our communications. First, I have to name it. So you'll see I'll just name it something appropriate. And again, I want to make sure this is what's going to secure our communication types. The defaults usually work really well, including PEM. And as you can see, it immediately creates that key pair in my EC2 on my AWS instance. And let's take a look at what that key or that file basically looks like. It'll download itself to my local workstation. You'll want to save this in a very secure location because this is what we will be using to communicate to our upcoming SV4PC array. Now, let's actually purchase and deploy our SV4PC in AWS. First things first, as I'm logged in, I'm going to go to my marketplace. I'm now going to start searching for our Spectrum Virtualize or storage Virtualize for public cloud. You can see that it's already suggested here. I'm then going to pick one of the particular instances. You'll see that one's a beta. In our case, I'll use that one right now. You'll see only the production versions. Once I'm in, I can actually then subscribe and you'll actually see the amount. We now have to accept those terms. And once we've accepted those terms, you'll see that it says go ahead and continue for the configuration. Here's where we actually get into the actual deployment. First and foremost, just use either your existing or a brand new VPC. I'm going to use a brand new VPC though. You can see that I can select which software and we'll use the latest. I'm actually going to use US West because I'm recording this from the western side of the United States. Now we simply have to go down under Action. Now we're going to create a stack here. Again, just click on Next. We have to name the particular stack. This is where we actually change our deployments of the VMs. As you can see, the node instance is listed up here, your choices, versus the quorum instance, which doesn't have as many choices. This is all about your bandwidth and your performance. And if you want to actually have more than one node so that you can have more choices for deployment, I'm going to put in a password. This is where I put in my IBM customer number. This is where I'll put in my IBM address that I'd like to be notified at. Of course, you'll use your own email address for notifications. This is very important as you'll get key information on the deployment this way. This is where we'll actually select that key pair that we created earlier. In this case, I'll make it public so that I can get to it from anywhere in the world, but you can do that also by private and then using Bastion or other VPN methods. I'll choose West because I'm on the western side of the United States. The rest of the defaults are just fine unless you have specific needs inside your VPC. That's why I'm creating a brand new VPC so I don't have to worry about that. But if you're deploying into an internal VPC, this is where you'll have problems or things to work out. And of course, because I'm doing this publicly and I want everyone to be able to get to it, in this case, which I don't recommend for a production, I'm making sure it's wide open. This is where you're actually going to put how much disk space you would like to have available for your SV4PC. I'll leave it at 512 because it's just a demo. And you'll see that I just have to simply accept the license and click on Next. The rest of the options are all defaults. You'll see I'll roll back in case there's something wrong. And now I'll just make sure everything looks correct. You'll see that I've re-verified my ID and passwords, that I'm using a public IP, that I'm using a key pair that I have previously created. And this is again making sure about which nodes I'll be using and how much backend storage, my email address. And if you want to add more tags, this is where you can add as well. Most importantly, down at the bottom, we have to go through these two checkboxes and then click Next. Once we do that, it'll actually start deploying. Now I've sped this up so that we don't have to wait for all the deployment. On AWS, you can expect it to be done in about 10 minutes to 15 minutes. I'm going to let this play out so you can see how many different steps it actually does. Notice on the left-hand side, you'll see that it is actually 2 different series of batches that it's going through. And you can click on refresh over and over again. You'll see that it actually becomes green as it creates and completes. And then finally, when everything is done, we'll have just completes, and it'll be all green. Meanwhile, we can actually take a look at that quorum node, which is what we're going to be connecting through. You'll actually see that while it's still initializing, I already have my public IP address that I'll actually be connecting to it. And if I go down through the view details here, you can see that it's already starting to run. It's still provisioning, of course. But if I go to the tags of my quorum witness, this will actually give me some very interesting stuff. Not only, of course, it's being deployed, that it's also public again, that I'll have a public IP address. We can monitor it as well. But the key thing here, especially on AWS, is right by that tag is this other tab, which shows that you'll be going to SSH to issue some commands right after deployment. And you'll see that highlighted here. And I'm just waiting for all the completes to happen. You'll see that one of the tasks, the batch, has actually finished, and the other one just finished right now. So as you can see, let's take a look using that private key that we just talked about that I saved on my local hard drive. I'll be using that to actually communicate through the Bastion into our new SVPC. First, I have to change those permissions, and then I'll SSH using that key, and I'll connect in, and now you'll see that I have a simple command just to make sure if I want to command and use a GUI set of commands, I can do that as well. Otherwise, you can do it only through the CLI. Now that I've enabled that GUI to be found, I can actually connect to it over the public internet. So I'm going to connect right now. You'll see that I'm entering in the password, which I entered in earlier. And I'll sign in. And again, remember, you can do this all through the CLI as well, but it's useful just to see this in a graphical sense. Now, before we finish up on that, I just want to make sure that I show the CLI version of this via the Bastion. So once it's deployed, if you want to get into that particular quorum node, we can get into it not using a public IP address, but using your AWS account, using Session Manager, and using the Bastion service of AWS, using your account, you can actually log in as a super user to that particular VM. And as you can see here in the upper left, it's just a standard VM that's hardened. And now I can show you that I am logged in as the super user from our friends at AWS. And now I will sudo back into the standard account. Now, as a regular user via the sudo, you can see I'm just the root user now on that Bastion host. You can see that I'm in my root directory. And all of this can be done, if you want, using a YAML file as well, which I'm showing you on screen as well. But you can actually now see that key pair, and you could then SSH into the host and finish the steps. We're going to do this all through the GUI, though, in step 3 here, setting up the flash system array or the SVPC using the system setup GUI set of screens here. But you can do this also through the CLI. Basically, accept the license terms. We will be forcing a brand new password for the super user account, which we set up during deployment originally. So you'll be using the old password as well as making a brand new password. This is how we're going to name the system. And again, depending on your licensing, if you want to add any more external virtualization or other items, we then confirm the browser settings, date and time, and then simply click next and determine if you want to use the iCloud services or any other call homes for your instance. You can actually see that we can do this using email or setting up call home later, which is what I'm about to do. As you can see, I simply click on next to review everything. You can set up the call home at any time. Once it's completed, which you'll see by clicking on close here, you're into the actual dashboard, and I'll actually show you just the same exact setup that we'd do with an on-premise one. And again, it's reminding me about call home. You can see that unlike a regular hardware piece of appliance. This is all software, so you don't see any pictures of hard drives or flash drives or anything else like that. Let's compare a little bit because I'd like you to see what an on-premise flash system looks like. This is a 9500. You can see that in the same area under monitoring and system hardware, you can see the flash core modules. You can see that also in the upper left where it actually says flash system 9500 versus the SVPC, which will be in the upper left-hand column. You'll see that right here. Spectrum Virtualize for Public Cloud. And now let's show you how easy it is to then finish the deployment here. You can see that I have those two M disks from our deployment. Both of those are 512s. I'll grab both of those M disks right now and put them into a brand new pool, and the defaults work just fine. You can see down below the provisioning policy, which is very similar to the other policies that we've talked about. So you can actually use that if you want to enforce various provisions or turn on data reduction for this pool, which would enable data deduplication. I simply click on create and then close once it's done. This has now taken those M disks into a nice pool that I can then provision for volumes to any hosts. I can assign those M disks to other pools as well. This is also how you would then add other disks from Amazon's EBS into your SVPC. You can see that inside the pool, I now have those M disks, which are assigned, and now I would simply create a volume and then assign it to a host. Here's how I can create that volume. For a test, I will simply have as 1 gigabyte, and then I will name it and then click on save. And now as you can see, the GUIs not only confirm that I actually have that volume, but I can also map it to a host once I define a host as well. Here's that one volume, and now if I want to map it to a host, simply right click and I would actually use any of the hosts that I defined in my SVPC or in my virtual PC. This is the end of the actual deployment because it gets very specific to your environment. Thanks so much for watching, and I look forward to talking to you in person in an upcoming TechU. Feel free to reach out if I can be of any help, or as well as any other Redbook authors. Look forward to helping you and seeing you in a future IBM event.